We're starting a graphing assignment, and I don't normally put my settling ins on a tutorial to show you, but I think it would be helpful before I talk about the graphing assignment to give you kind of example that we did in our settling in, and this is very similar to what you'll be doing in the assignment. So it says number 2, for the first graph, show what is happening in terms of speed. Don't state the rate and trend, but rather just tell me in plain English. So if you look at this line here in the first graph right here, what's happening? Now, as you get used to this, you'll be able to say that the object is just traveling at a constant speed. Let me switch pens here. Constant speed. Now, I put numbers on my graph because that might help you to be able to see that. You guys know that speed is equal to distance over time. Well, if I have a time of 1, I have a distance of 1. So 1 divided by 1 is equal to a speed of 1. 2 divided by 2 is equal to a speed of 1. 3 divided by 3 is equal to a speed of 1. So everywhere along that line I have a speed of 1. So a constant speed, which is also telling us that there is no acceleration. Okay. So I've done number 2 and number 3 now. On the second graph, draw what it would mean to show the same thing as in the first graph. So I just told you had a speed of 1, and the speed isn't changing. So on a time speed graph, notice my variables changed, it would look like this. My speed is always 1. And if my speed is always 1, I'm not accelerating, so I would have an acceleration of 0. Now, for your graphing assignment. This will probably take us 2 days. What you're going to do is download the graphing assignment online, and students are drawing each one of those on a large sheet of paper. If you don't have a large sheet of paper, you can actually probably just print it and do it right on the printed handout if you're absent. The first day of the lab, we'll probably get about 5 of them done, and then we'll try to finish the rest of them on the second day of the lab. And what you're going to do in each graph is try to tell me what's happening in terms of just the everyday object, what's happening in terms of speed, what's happening in terms of acceleration. And then if there's other things you could work out, like some of them have numbers on the graph, you could put figure out things like their actual speed sometimes, etc. Okay, so let's show you what that might look like. So these are just the first page of the printed handout. Just tells you distance versus time graphs and speed versus time graphs. And what you're going to end up doing here is the directions are kind of printed down here for you, and you're going to focus on these things for each graph. Alright, so let's do the first one together. What's happening to this object? Just in plain English. I don't want you to say as time increases, distance stays the same. That's not what I want you to do. I want you to tell me what is happening to this object. Well, you don't have to, but it might help to label it with numbers. So for example, if we put a 1 here, a 2 here, and a 3 here, and over here we come up with some distances. Maybe we have a distance of 10, 20, 30, and we'll make the line at 40. And sometimes it's even helpful to put a location. Maybe we say at 40 is McDonald's. I don't eat there, but anyway, we'll just pretend. So if we take a look at this, at time 1, or a minute later, you are at 40 miles away from home, or you're at McDonald's. Time 2, 40 miles away from home, or you're at McDonald's. Time 3, you're at McDonald's. So what you would do is you would tell me what is happening in this case. In this case, you are not moving. So you're not moving. And what is your speed then if you're not moving? Speed is equal to 0. What is true about your acceleration? Well, if you're not moving, you have an acceleration equal to 0 also. So in this case, I would be done with graph number 1 if I figured that out. Okay? And then you would just go on to graph number 2. State the same thing for graph number 2. Again, you're welcome to put numbers if that helps you solve the problem. Add some simple numbers to your graph, 10, 20, 30. Okay? Now, if you can't see by looking at this what the object is doing, calculate the speed. Okay, distance over time. I would take 10 over 1 in my case, 20 over 2, 30 over 3. Okay, and you'll see if I divide those, I always get a number of 10 meters per second or 10 miles per hour. So I always have the same speed in this graph. So this graph is showing a constant speed. And if I have a constant speed, I have an acceleration equal to 0. So what might this object be doing? This would be equivalent to just driving down the freeway at a constant speed. So now in this one, number 3, you have 2 lines. Compare the 2 lines to each other. You just learned that a straight line met a constant speed. And again, put numbers on here if you have to. Figure out what is the relationship between line A and line B and go from there. All right, and I'm going to stop doing them for you because I want you to do these on your own. So go ahead and work on those and come ask me questions if you need to. Thank you.